Okay, let's go ahead and get started. I can see we are a cozy little crowd. I know it's late in the afternoon, so I guess we conclude with that this is the dedicated people that are in here that really wants to hear about this. And we are also here to really tell you about the learnings that we have. So let me start with presenting myself. My name is Anders Remmenholt, and I work for the Windows Server and System Center engineering team in a team called the CAD team, which is Customer Advisory Architecture and Technology team. And our job is actually to go out and talk to customers out in the field and get an understanding of what the real world looks like. Some of you might sometimes be thinking, those people that coach these products sitting in their own little cubicle, and they don't know what the rest of the world is about. That's exactly what we're trying to fix that problem, to reflect or go out and talk to the real world and take some of those features and move them back. And that is exactly what we have done this year. We have worked, Ricardo and I, the past year or so, traveling around to service providers around the world and implementing Windows Server and System Center solutions at these service providers. And that is exactly what this presentation is about, telling you about those learnings. We went out there. You just want to give a presentation of yourself,
Sure.
and then we can...
So I'm Ricardo Machado. I'm an architect in our data center Center of Excellence. So we're a worldwide team that supports Microsoft's own consulting business. So our job is to support our pre-sales motion and our delivery of engagements to our customers. And we've been involved with the CAD team this year in a very special program designed to engage with service providers. This session is, like Anders said, the learnings that we had from that program, and we'll share it with you.
Okay, so the objectives. We want to, of course, tell you about how we went out and did this. So how did we implement Windows Server and how System Center can be used at a service provider. And, of course, we also want to talk a little about, that is what I have values for you, some of the challenges that we ran into. Some of the things where we had to sit down and think about what's going on here. The service providers also had to kind of give a lot of feedback. That is some of the stuff that we want to give to you today. And then lastly, also, of course, show how we came up with solutions to some of those challenges, so you also can go home if you have a similar challenge, and hopefully you can take a solution out the door when you walk out later today. So as it says here, it says service provider in the title here. So let me see some fingers. How many of you are service providers, hosters, cloud service vendors? Okay, well, that's quite a bit of hands. So I hope that when you walk out of here, you got exactly what you came for. So the agenda is, of course, going to reflect the objectives quite a bit. So we will start by talking about service providers and why they are different from the enterprise. Those of you that are service providers, of course, know that, but we just want to set the scene about how is it we see this being different from any other enterprise. After that, we want also to give you some insight if you say, hey, we're thinking about really hard coming up with design patterns, or at least design our own infrastructure. And here we want to give you some pointers and some high-level conceptual ideas and pointers to how you can go out and put this together. What we learned when we were doing this program is that we thought, okay, these service providers is going to be very, very similar, and once we've done one, we have the whole thing set up, and we can more or less just put it in a photocopier, and then we have all the designs sorted out. That we were very wrong about. That we had just as many flavors of service providers, and where they cut their kind of boundaries everywhere in that layer, either at the top or at the bottom or in the middle. So it was very, very different situations that we were out seeing there. And that's what we want to go over, what we learned there. And then, of course, when you walk out, we also want you to point to say, that was really good what Anders and Ricardo was talking about. You can see these PowerPoints. But we also want to give you some of the materials and some of the tools that we have on the Microsoft websites or different places that you can take and download and use right away. So you don't have to start from scratch. You can take this, read these papers, and at least get an idea of how we did this. And you can sit down and at least get inspired and see if you can use any of this. So I guess many of you went to the keynote on Tuesday with Brad Anderson, where he talked about the Cloud OS. So the Cloud OS is here to stay. It's a new concept, or a fairly new concept coming out from Microsoft. But what we really mean by this Cloud OS is that it's an OS that can run in any cloud. And for those of you that went to Jeff Woosley's session and some of the other sessions throughout this week, we're talking about the 3 different clouds that we have. The idea with the Cloud OS is that you, or at least as a customer of consuming those services, either if it's from a service provider or it's from internally inside your own IT organization, that we want you to have a seamless experience of no matter where you are, you have a standardized way of using either a console or a GUI or using APIs or using standards across. So let's say you create runbooks that you want to use, that you can use those runbooks for automation across these clouds on-premise, at a hoster, and up in Windows Azure. So that's one side of it. So we want to transform the data centers to bring a consistent experience to you in various ways. The other thing we, of course, want to is to empower people-centric IT. So Brad Anderson talked a lot about this, and what we mean by that is also that we want to drive some of the management capabilities that we typically see today to the other areas as well, such as development, management, data, identity, and virtualization. We want you to have that consistent experience across these clouds. So Azure has been around for a little while. The private data center has also been around for a while. But one of the very big focuses we have had for both Windows Server 2012 and from System Center SP1, and also what you will see with R2, is that there's a lot more focus on service providers. And it's because we understand, or we are working on understanding and implementing solutions to some of those challenges that you are seeing as a service provider. That goes of the notions of a tenant, it goes in notions of authorization, authentication, the way you can present data, expose that data, GUIs and portals and similar things like that. So if we take that a step further here, we can see here with Windows Server and Windows Azure that this is a synergy that goes. And what Brad talked about is also that we learn from the clouds that we have already. And those of you that already remember that Claire Henry was up on stage at the keynote presenting the Windows Azure Pack. This is a very powerful example of how we learned about the GUI and how to provide that experience up in Azure. And then we took that exact experience, took it down on-premise. Just one example. But many of the other things like software-defined networking, high-performance storage solutions, application, electricity, and multi-tenant environments are all things that we have done for quite a while up in Windows Azure. And those functions or areas are the ones that we want to bring down to the service providers and to the enterprises so they can benefit from these functions. So if we talk about cloud, there are some drivers that drives this cloud experience that you as a service provider, of course, is thinking very heavily about. So secure isolation between tenants is one thing. So really one of your challenges, that at least that they told us, is that they don't really want to be in a situation where they dedicate the fabric layer to specific customers, and then they're not able to utilize these fabric resources to a degree that gives them a good cost model. So really what they want to do is to share the underlying fabric between customers, but that brings another challenge where you want to say, even though I'm running multiple tenants or customers on my fabric, I want them to be 100% isolated from each other, which we normally refer to as the Coke Pepsi scenario. At a no given point in time, we want them to be able to see each other. So that's one aspect. Resource metering is another area that we talk to a lot of service providers about, where we want to send the bill and charge those people that actually use the resources that you have on your backend, so you can earn money based on a billing model that you have. And the better in control you are with this billing model, the better control you have over your income of money that flows into the company. So therefore, what we were told by the service providers is this is an extremely important piece for us because this is what justifies our existence, that we understand the way that we build our customers, and we can be transparent, and we can actually be fair about it so everybody understands why they are paying what they're paying at the end of the month. But also at the same time, be able to charge at a lower frequency that most of them are doing today, maybe by monthly or by daily, even going down to an hourly basis, where you can go down and say, this machine has only been powered for 8 hours today, then we will only charge the customer for 8 hours based on our charge/cost model. Then another thing we heard consistently from service providers is quality of service is very important. Because what that gives you is that you can ensure that no one is over-consuming what they're paying for. Of course, as a service provider, you want to be able to differentiate what you're providing to your customers, which we often refer to as gold, silver, bronze solutions, where if I buy a gold, I end up on a very fast server with a lot of memory and a lot of fast disk. But if I end up on a bronze, I have much lower fabric resources available. And of course, you don't want somebody that is paying for the bronze to get gold resource consumption. So that's why you want to price differentiate those two. And quality of service plays an important role there, because this will ensure that nobody will not have faster I/O to a disk or have access to more CPUs that they are in fact paying for. And then the last thing that would help a service provider bring down the fabric cost per VM is to be able to be flexible about where these VMs are in fact living inside the infrastructure. So if I have a VM running over here, I want to be able to move that to any given host inside my data center, so I'm able to share my load from different tenants over as many servers as possible and bring the numbers of VM per server up as high as possible to bring down my fabric cost per VM. So if you look about it, or if you think about it, we are starting to see a trend around here that we normally refer to the race to the bottom to drive down costs for the service providers. So one of the most important things for them is to make us be agile, make us faster, make us go quicker to market, but at the same time drive down costs. I don't think there's a service provider that doesn't have that initiative or that goal. What we also learned is that there's more and more, let's say, service providers or big service providers that are just, and don't get me wrong here, but that are providing VM hosting or are providing private clouds. So the only thing you can do here is to try to be as efficient as possible and try to minimize your cost at the fabric layer and then see how cheap you can actually build a VM and then put a profit on top of that, and that's kind of the money that you then earn. But providing a VM is, at least what we're starting to see, is beginning to be a little bit commodity, where people say, we want more than VMs. We want more capabilities. We want more. So just delivering VMs today is, for many hosters, at least where we're seeing the trend going, not enough. What we're seeing, if we see customer value and complexity on top of that, is to start to provide simple services on top of that. That could be SQL servers, that could be websites, that could be other simpler services that the customers want to put on top of these VMs. They want it to be self-service, they want them to be automated. In fact, they don't really want to do very much in order to get these services. They just want to log into this portal. The other thing we're also seeing is that many, or some service providers, let's not say many, wants to take it a step further, where they start to put in advanced workloads on top of this, such as SharePoint, Exchange, and Lync, and provide that to the customers. What we're hearing sometimes is that they say, okay, where we want to differentiate ourselves compared to, for instance, Office 365 or others that are very, very large, is that we want to be more flexible. So customers that doesn't necessarily fit the Office 365 or similar solutions, they can go to a service provider, and then the service provider say, yeah, we give you Exchange, we give you SharePoint, we give you Lync in your own instance where you can do whatever you want to it. We have it fully automated, and you can go into a console and order all this. You pay a little more, but on top of that, you get your flexibility. And a lot of customers are looking for that if they're not ready to move to the cloud. There's always a time and a place where you can move some stuff up to the public clouds, but many tenants or customers want to have a stepstone in that journey, or many of them have compliance setups that prevents them from doing that, so they might never go up to the public cloud. And therefore, they're looking to the hosting provider or the service provider to give them that capability. So that's what we're seeing here. Now, what we're also seeing is that the more customer value you bring and the more complexity you put into these offerings, the more you can charge per VM. I mean, that's obvious that there's a limit to how much you can pay for a dumb Windows Server 2012 running with 2 gigabytes of RAM and 2 CPUs. That is kind of pretty low these days. But if you say, hey, I give you a full Lync environment with automated provisioning of users and all this stuff on top of that, you can charge a lot more for that VM than you can for just a VM running. Then on top of that, what we also heard is that other areas that many of these service providers are looking into is system management, where they say the exact same thing, that I can charge more for a VM that runs Lync, but I can also charge more for a VM that runs monitoring, backup, patch, and other similar solutions because I bring more value to the customer. So if you can do a combination of providing Lync and monitor that service, you're starting to get a lot more per month for that VM, but at the same time, the customer also gets a lot more value for what they're buying. So a win-win. So when we look at the service providers, we always run into this concept of multi-tenancy. So the multi-tenancy is really the essential attributes of cloud computing that specify how we can separate data security and privacy, performance, and scale, meaning that if I have a tenant 1 that suddenly goes berserk and start using spinning up a lot of new VMs and put a lot of heavy load on those, it should not impact another tenant. Also, at the same time, any of that data or security should not be shared with another tenant, as well as we want a service provider to be able to scale very rapidly without hurting any other tenants. So we kind of need to control that someone can suddenly go berserk and just start provisioning. So here is the roadmap to multi-tenancy, at least the way that we talk to the different service providers about it. So on the first one, you kind of see explicit separation between them all the way from the service layer all the way down to the hardware. And this is very costly to run an infrastructure like that. But there are some service providers that are forced to do that these days. It would be service providers that has government institutions or finance institutions might be forced to live over in that world. There can be where you have tenants that have special insights into it, where they share the app across. Some of them would say Exchange as a service could be where that is the case. And then we have the one infrastructure tenancy, which is probably the one we see the most, is where you have the tenant, the app, and the data layer separated, but they share the fabric. That one was probably the most common one we saw out there. We had a few ones where they were a little bit deeper and a little bit upper in the layer. That was the most common one. And then we have the shared tenancy. That's probably what many would think about just as, it's more like a cloud service vendor scenario, such as Office 365 or CRM or similar services that you would see in that category there. So the structure we went out and worked with here with the service providers was that we did this in 3 steps. So the first thing we wanted to sort out here was to say, let's build your fabric first. Meaning, let's set up those Windows servers. Let's get a standard defined. Let's get a pattern design built and kind of describe the foundation for how we want to build the fabric. Once we have set up a POC of this fabric with the cluster and these resources, what we did, either in parallel or shortly after, we set up the management infrastructure that should then go in and control the fabric so we can manage that. So that means all the System Center products, Operations Manager, Orchestrator, Virtual Machine Manager, and putting that on top of a Windows cluster and have them manage the different fabric resources that we're then putting into the infrastructure. Lastly, we then built the self-service side of it, which we defined as App Controller or the Windows Azure Pack capabilities, so users could log into this portal and start self-servicing themselves. So with that, I want to hand it over to Ricardo, where he will talk a little bit about some of the design patterns that we use as these service providers that can inspire you how to go and do similar things.
So one of the primary, and like Anders said, the three major blocks of design, we need to start with the foundation. So compute, storage, and network are what we define as the fabric. The fabric is the foundation where all the tenant workloads live, and maybe some of your management or all of your management works can also live. And we basically have what we call our product line architecture. So these are basically a set of design documents that highlight the preferential patterns that we have for deploying Hyper-V and System Center for not only service providers, but in most environments, so for enterprise and in this case for service providers. We look at these documents as something that takes a lot of the experience that we have running these engagements. We gather the best practices in deployment. We basically allow you to get a lot of the investment that Microsoft has in terms of all the customers it meets, all the design sessions that we have, because we compile all that information into this set of documents. We have links later in the presentation to this guidance. It's available to you. And it's basically the first pillar that we have for designing our fabric. So we have a typical set of patterns that we have identified with our customers. They're mostly known to pretty much everybody in the industry. And these patterns, the three primary ones, is what we usually see in these engagements that we have with service providers. So the first one is traditional model, where you have your compute and you have storage stored in what we call traditional SAN environment that's either accessed through Fiber Channel or iSCSI. So in the PLAs, you will find very specific guidance on how to access each of the details for both the Hyper-V, the network design, how we do the storage access, so multi-channel configuration, MPIO configuration, LBFO and teaming. So all these aspects are covered in extensive detail. The second pattern is typically found in customers that have preference for blade servers, so blade setups, where you usually have converged networks. You have basically a shared setup of network both for the network access and for your storage access. And this pattern is also very, very popular among service providers. Finally, the third pattern is what we call continuous availability over SMB storage. So this is something that it's more recent in terms of availability. SMB storage was supported only on Server 2012. It was something that the previous versions of the Windows Server operating system did not support for storage of virtual machines. And inside this pattern, we found a certain variations that you could use for deployment. So the first one is our storage spaces story. Here you have basically a set of servers that function as storage heads that access a set of shared JBOD arrays through SAS controllers. And this storage is exposed through SMB3 through the Hyper-V clusters. So we're not going into a lot of detail as these protocols. Basically, the event is, of course, full of sessions from the PMs, from these features, where you can literally dig into the details of each of these things. So we're not covering these into a lot of detail, but there's a lot of content in TechEd where you can find that. So the next one is basically using the same concept, so the SMB3 access to front-end existing storage solutions, okay? So you have basically an investment in Fiber Channel or iSCSI. You really don't want to change that. You're comfortable with that investment, but you do want to have the benefits of SMB3. So in this scenario, you front-end that storage through what we call the scale-out file server that basically exposes the existing storage configuration to the Hyper-V and allows Hyper-V to use the benefits of SMB3. So in this pattern, there are a few highlights as to the network setup that we prefer the use of RDMA cards. So there's very specific guidance on how to set up the scale-out file server and how to take the benefit of separating your compute scalability from your storage scalability. Finally, so SMB3 is not only a Microsoft story, right? We have a multitude of partners that are enabling SMB3 as part of their SAN solutions, right? Their NetApp, EMC, and others are building support natively for SMB3 and allowing you to connect Hyper-V directly to this equipment and also gain those benefits. So in terms of some of the learnings we had from deploying here, I would like first to ask you, some of the audience, what is your preference or what do you use today in terms of access of the network? We have basically 3 more. There are probably other options. But if you could just a quick raise of hands, what's your current use of these? So first up, mix of 1 gig and 10 gig. So I think half of the room, right? Just 10 gigs, much smaller subset, and still just 1 gig. Okay, thank you. So, and I can tell you that this pretty much sums up what we saw in the field, right? From left to right, those were the primary options that we saw. So customers are mostly cost sensitive still to the cost of 10 gigs on the switch side. So the ports are still somewhat expensive compared to 1 gig. And we saw pretty much customers taking advantage of 10 gig where it made sense for them and using 1 gig and reusing existing equipment that they had to leverage as much of that investment as they could. So there's a few challenges in scaling some of the existing designs. So VLANs is a concept that pretty much everyone in here is familiar with. However, in some customers that were trying to scale to huge amount of tenants, so we had examples where customers partitioned their infrastructure to deal with the number of tenants that they use. So a simple setup would be to have a scale unit that cared to 1,000 tenants, and each tenant would have 2 to 3 assigned VLANs. And then they would just replicate this over and over just to deal with the fact that they had no more available VLANs. So setting this up and configuring this was a huge, huge challenge in some of these customers. So also other issue is the connectivity aspect. So creating an environment where it's easy to a consumer of this service to connect to your environment is also very demanding. So it is a complex setup to create a working configuration between an enterprise that has a lot of requirements, that has an existing set of IP addresses, and connect that to an existing network also on the service provider side. So software-defined networking is seen as the way to go. However, getting there, right, is not an easy task. And there was a lot, we found that the market was still not very knowledgeable of not only our solution, but other solutions in the market. So service providers still pretty much grasp to VLANs. It's the way they've done it all the time, but they are very aware of the challenges. So just a small refresh on our software-defined solution. There's also, at other sessions of TechEd, a lot of detail into these. So separating the tenant networks from the actual service provider network is the biggest benefit here. The fact that you can provide your tenants the ability to create networks, to have a self-service network experience that provides that isolation that is required, is also another benefit. And this without touching your service provider network, without going to your physical switches and reconfiguring VLANs when you're provisioning a new tenant. So these benefits are basically all the things that service providers are looking for, but what we found during the year, that there's still a big resistance into adopting this. Okay, so new technology, a lot of investment into learning, so this is the way forward. So other challenges, and here we found that a bit of the legacy knowledge that exists in the field with our technology is a bit of the driver here. So combining our teaming solution, LFFO, and the Hyper-V switch, right? We found that a lot of our customers who work with Hyper-V in the past, in previous versions, and used partner solutions to configure teaming, had a very strict set of guidance from those partners on how to set it up. And what we found is that they usually replicated that setup in Windows Server 2012 to, unfortunately, very poor results. So what you should always do in a situation where you have to combine LBFO with the virtual switch is to delegate the assignment of any VLAN networks to the virtual switch, okay? So if you have a situation where you have, for example, two 10-gig adapters, and you need basically to provide high availability, you should create the LBFO team on top, then put the virtual switch on top, and at the virtual switch level, create those virtual network adapters on the Hyper-V management partition, and expose those VLANs through virtual network adapters. So we found a lot of customers doing this, okay? And this is basically creating those same VLAN networks, but doing that at the LBFO layer, okay? And then on the side, they would also bind the virtual switch to the same team, and this is something that we definitely don't want to happen, okay? It's in the guidance that we provide, but it's sometimes not fairly well known, and this we found at a number of customers. So other example, and basically a combination. So if you have the ability to have more network adapters and you only need the virtual switch, or if you only need to connect virtual machines to a subset of those adapters, this is a configuration that you can use, okay? So if you have adapters that don't have the virtual switch, it's fine to create those VLAN adapters right on the LBFO configuration. We've attached some of the PowerShell required to create the configuration on the left side. So if you can refer to these for guidance. Other conclusions that we found is there's new ways to set up our failover clusters in terms of the network configuration, quality of service, the NetFT adapter in Server 2012 R2, the fact that we can now use SMB3 for our CSV traffic. So there are multiple things that we have introduced in failover clusters that allow us to think differently in how we design networks to support these failover clusters. There's a great session from TechEd North America from Eldon Christensen that goes, it's a full session just on that specific topic. I urge you to see it. And if you're designing failover clusters with newer versions of Windows Server, it's definitely good content to be aware of. So one of the other conclusions is a lot of these service providers are still running iSCSI with 1 gig links, sometimes multiple of these. Designing and using a network configuration is mostly a question of balance, right? The size of the servers you have, the type of storage you have, and sometimes providing 10 gig adapters to servers isn't necessarily a good thing in terms of having a good balance in terms of cost. So we're seeing still a lot of these service providers still just using plain old 1 gig links, multiple of them sometimes, to achieve their goals. Also, a lot of these internet-facing networks are still always using, or most of the time still using also 1 gig links. So on to storage. Again, a few questions. Who in the audience is already using SMB3? Well, just a few. Okay. iSCSI. Okay. And Fiber Channel? Oh, wow. This is a bit surprising. This is already quite different from what we found. Okay. So to be fair, our objective was also to provide to the field, to our customers, a good insight into SMB3. And we were somewhat successful. We got significant adoption of our SMB3 storage. In multiple designs, so what you saw earlier in the patterns, we had basically a good spread of that in terms of what the patterns look like. So one of the primary characteristics is the larger the service provider is, the easier they adopt the story. The reason this, I think, is they already dealt with the challenges of configuring iSCSI and Fiber Channel at very large scale. Okay? And SMB3 provides that independence between your Hyper-V hosts and your storage. So you can scale your Hyper-V independently of the storage access. So storage is configured, and when at the time, if you don't need to scale it, if you don't need to grow, you don't need to think about it while you still continue to grow your fabric for the compute. Some of the service providers who use NFS, which is a similar protocol, immediately understood the benefit, and by themselves, so without any intervention or intention from our side, immediately grabbed the story and went with it and went into production with it. So if they're already using this from competing platforms, they understood the benefits immediately. So SMB3 is basically bringing a lot of the benefits of other competing technologies and providing them in a very easy way to configure. And also with RDMA and specific hardware that supports it, basically providing that very high performance and low latency scenarios also. So it not only provides the ease of setup, it can also scale to performance environments. Okay. So, and as we also referred, the scale-out FS, so the solution, the multi-server, the multi-file server solution, the active-active solution, is also used in sometimes to front-end existing environments. So some of these customers that deployed SMB3 kept their investments in their existing sense. So behind that SMB3 solution sometimes sits an FC array or an iSCSI array. Okay. So iSCSI is definitely, and a bit contrary to what we found in the room, iSCSI was the existing setup. So when we arrived at these customers, the most well-deployed scenario. Across the board, the service providers were mostly using iSCSI. For some of these, we found some design challenges when we had a design where we required the iSCSI traffic to go also through the Hyper-V switch. At the beginning, where we started to engage with the service providers, the solution was not fully supported from us during the time. So over this time period, we rectified that situation. So you can now create multiple virtual network adapters that you bind to that virtual switch, and you can configure multiple paths that go to the virtual switch to address this. Also, we found very limited use of iSCSI boot. Actually, in pretty much, with the exception of one customer, no one used iSCSI boot.
How many of you use iSCSI boot, just to see?
No.
Nobody?
Yeah.
Okay.
So everybody runs disks locally on their boxes, boots from local storage. We found that to be the most prevalent side. We had one customer where we found this to be used. And finally, Fiber Channel. We found it to be only a subset of customers that were providing similar to enterprise-grade offerings to the market. So they were providing or selling, pitching a premium experience where they would replicate an existing enterprise scenario to their customers. So we found that they were pitching a solution at a very high price point, and to justify that price point, they were providing exactly what the customers knew. It was most of a comfort to the customer to understand that they were buying a premium solution. Okay, we could challenge here or discuss if they could achieve the same result with SMB3 or iSCSI. That was not the point. This was it was two customers, and their foundation for selecting FC was basically to provide comfort for the customer. So in some cases, we continued to use that FC investment, and we also had the customer, in this case the service provider, try our scale-out file server as a way to access the same FC array that he already invested in. So we mentioned a bit before the concept of VLANs and the way service providers are very much attached to thinking of the network as the primary mechanism for isolation. Our SMB3 storage solution provides isolation through ACLs, right? Active Directory, the computer accounts that Hyper-V uses to authenticate to that cluster is the way we secure access, okay? And on some of these service providers, some of them, this was the first time they were exposed to Microsoft technology. They were always, in the past, using other competing solutions. And trying to explain this difference was challenging. It is the minimum I can say. So from a world where everything is isolated through creating a set of independent networks that then share the same storage heads, share the same network switches, was very hard to translate into a world where you're protecting by security principles and authentication. Okay, it's a very different mindset, and if you work trying to sell these solutions, you might find this challenging. Who here has a similar setup where you provide isolation to storage through independent networks for different tenants? Some of the service providers in the room. Okay. So glad to, if you want to discuss this point a bit after, I'll be very interested. Other design issues that we faced with our own storage spaces solution with only dual JBOD scenarios. So storage spaces can basically use a shared JBOD scenario where we can cluster basically and provide high availability for that. But in this dual JBOD scenario, storage spaces will require an extra disk. Okay, this is also new in R2. So that to provide the quorum for that cluster, there needs to be a disk majority in that scenario, okay? And a lot of customers were not aware of this, and they looked at their traditional dual enclosure setup as a minimum setup that would work for them. And finally, support for some of the management protocols and ODX was also, and please consider that we run this program from the launch of Server 2012. And at the time, we still didn't have System Center 2012 SP1, so these things were coming to the market. So lack of support for these protocols, some issues we found. There was a very severe issue with ODX that we still today recommend that you disable ODX if your storage does not support it. So if you have Server 2012 and your storage does not support ODX, we explicitly tell you to disable. And so we found some of these issues during our engagements with the service providers. In terms of compute, again, basically blades, a bit of everything, and traditional rack-mounted. Who's on the left side? Just blades? A mix? Okay, and rack-mounted? A bit of everything, I guess. It's a spread, just like in the room. I would say that the bigger prefer the rack mount to the point that they build their own things. They have their own factories, they buy the components, they build their servers. Some are very attached to the converged scenario. They really like it, and it's a choice. There's no good and bad. Some of the smaller service providers are more into a business of providing a custom offering, and where extreme standardization and driving the cost down of building the compute layer is not so concerning to them. They are competing on a service level and on a price level that they need to cater to that very specific thing that the customer is asking for. So the bigger ones would definitely strive to have something very standardized, and that requirement basically came lower and lower and lower as the service provider was more of a niche player than a large-scale player. We also found that provisioning Hyper-V is mostly today done through traditional imaging. So someone either through the build of the server where the service provider had that factory model would automatically load an image that had some sort of automation to automatically connect to the existing environment. We found also some instances of using Pixie Boot, some different technologies to provision the servers. And I'll hand it to Anders for the design patterns for System Center.
Yeah, so as I mentioned before, we took a three-step approach to it. First, we defined the fabric. Secondly, we designed the management piece of this. So the way we do this, if I can get this one to click, is that we, primarily with System Center, we try to drive two challenges in this phase. We want to drive automation, and we want to drive standardization. It's very hard to automate on something that is not very standardized. So the harder we could drive that, the easier it would be to automate on top of that. So we started with having focus on the tools in System Center that could help us with driving that automation and that standardization for the virtual and for the fabric layer as much as possible. So typically in the first phase, we went ahead with building the management cluster that I talked about. Then Virtual Machine Manager, put that in there, 2012 SP1. Then Orchestrator and Operations Manager, depending on the requirements. Typically, Orchestrator was used to help build the fabric faster. And Operations Manager was, of course, to understand how they could better utilize their resources that they were providing in the fabric layer. And then, very commonly in phase 2, we were looking at the Windows Azure Services for Windows Server, also known as the Windows Azure Pack, and App Controller to provide the self-service experience. Configuration Manager, Data Protection Manager, and Service Manager were used where customers had explicit requirements to use those functionalities. So when we look at the management cluster here, we normally go out and we build these resource pools that we talked about when we were defining the fabric layer. So the way we decided to do this fabric pattern is to build a fabric management cluster next to it. So we don't put all the eggs that we have in the same basket, but we separate the management environment from the actual fabric environment. We still want to provide high availability so those don't go down, but we don't want to put them in the same basket as all the fabric. So it's really about the compute, the storage network, have the management cluster, control those, and then expose those in a private cloud manner where we put control over the resources that a given tenant could consume by defining that in private clouds. So what we learned here is specifically with Active Directory. Active Directory is very good in an enterprise, but you will run into certain challenges once you start using that in a multi-tenant environment. One might be that trust is typically, I don't think I've met a service provider yet that says, yeah, it's fine, just do full trust between the tenant environment and my backend infrastructure. The tenant will probably say, no, that's a very bad idea, and you also have a lot of reasons for why you don't want to do that on the backend infrastructure. Some choose to do one-way trust, but really at the end of the day, they really just want to completely separate it. But as many of the System Center products rely on AD authentications, obviously that brings some challenges when you're trying to do a self-service experience that utilizes System Center on the back end. So what we also learned here is that we also emphasize, or at least where possible, that you put your Fabric infrastructure and your System Center or your management infrastructure in the same AD. And we also suggest that you put your compute resources and your storage resources in the same AD, as though that is the technology that is used to actually authenticate and authorize across. So as System Center uses SQL Server, we were out talking a lot about how can we make SQL Server resilient, highly available. And many of you are probably aware that with SQL Server 2012, we came up with this, let's say, list of technologies called Always On. So Always On is a set of technologies you can use to make your databases highly available. The most common one that was also before Always On is traditional clustering, but then a new one was introduced called availability groups. From a System Center point of view, we do support Always On or availability groups. What we do want to emphasize is that as it's a new technology using this, we have seen good and bad implementations of Always On or availability groups where the customer or the service provider was not familiar enough with that technology that then gave them some huge challenges. So what we're saying is that you should, if you consider use Always On, make sure that if you don't have that specialty in-house, that you throw some money after getting a person in that it can help you set it up correctly for the first time. Because otherwise, we ran into some, I would say, combinations that we are not very, let's say, that is not optimal. So what we actually said here is that, let me just go back one here. If you're thinking about using SQL Server and you use clustering, we say use traditional clustering in the same data center. If you want to go cross data center, especially I would say there are two reasons. If you have very large environments where we're talking 10,000, 20,000, 50,000 VMs, you might want to consider using traditional clustering. If you have smaller environments, availability groups could be a way to go. If you do it between data centers and you replicate between there, Always On could be a way to go, and stick to standard clustering within the data center itself, especially if it's a large environment. Anything you want to add to that? Okay. So on the System Center side, we, of course, talk to many of these service providers and encourage them to use VMM and Orchestrator to manage the Fabric layer. And we wanted them to do that for two reasons, that we wanted to automate that layer as much as possible. First of all, so they could provide that Fabric layer faster, but also in the way that they would make fewer mistakes in that layer. And the reason for that also being that if something goes wrong in the Fabric layer, the impact of that error is multiplied by the numbers of VMs that is running on top, utilizing that Fabric piece. So by driving standardization and automation in that layer, we wanted to ensure that there were more consistency, but also that we knew when these were built, that they were built the exact same way every time. And therefore, we would claim that you get a more standardized or a more resilient environment. So as I talked about, automating the deployment at the physical servers and storage and networking as much as possible to achieve the benefits I just talked about. Also, use performance reporting to understand how you can drive a higher numbers of VMs per server in order to then ensure that you're actually utilizing your Fabric pieces in the best way. So it's not necessarily only per server, but we actually wanted them to look at the 4 resources that they use: networking, compute, memory, and storage. So if they could equalize their usage closer and closer to a higher percentage as possible, equally defined over the 3 resource types, that would be the best way that they could drive the most resources out of what they have, and via that, drive a lower cost per VM. So the next thing is the design pattern for self-service. So how many of you have heard about the Windows Azure Pack? How many of you have attended sessions about the Windows Azure Pack? Okay, that's good. Thank you for that. So what we started to focus on is, especially, we always wanted to work with service providers, but with some of the challenges that we had talked about with authentication cross ADs and understanding you're a user coming in, what tenant do you belong to, and all these different kind of challenges that make service providers different from the enterprise, we are coming with what we call App Controller and the Windows Azure, the Windows Azure Services, Windows Server, also known as the Windows Azure Pack. Here, we want to provide a consistent experience, especially with the Windows Azure Pack, between what you have in Azure down to what you have in the hosted space. The reason for that is, of course, that it's easier for people to work in an environment that they know from another place, but also that we wanted to provide a standardized platform in terms of APIs that customers could use, or service providers could use, at the same time as providing a standardized way of communicating with your backend infrastructure that gives you the management piece of it. And for that, at the top layer, we define the portals and the APIs that support these portals in the Windows Azure Pack. On the layer below, we have what we call service provider foundations. And the beautiful thing about service provider foundations is that this piece understands the difference between tenants, what users belongs to what tenants, and how we can map those tenants into rights in the System Center backend. And that's what we see down here with the Fabric stamps, that when a tenant comes in, I can create user roles in those stamps that define what clouds I can access and start consuming those resources in a multi-tenant way, where I don't have to think about how to authenticate and how to authorize these users that comes in from a tenant. That is built in within that system. So for those of you that don't know App Controller, that is a tool that we are using. It's primarily targeted at the enterprise, but the reason why we want to talk to service providers about using this in some scenarios is because this is one portal that you can use that can give you view into all your resources you have across the 3 clouds that we talk about in the Cloud OS. So on the one side, you can have your private in-house data center that is on-premise using Virtual Machine Manager. You can have a private cloud at a hoster using Service Provider Foundation that I just talked about, and then having Virtual Machine Manager underneath. And then lastly, you can have Windows Azure, where you host virtual machines up there. So the idea here is that you have your hypervisor underneath, and then you can start describing or defining to App Controller your subscription criteria to these different clouds, but then you provide those resources and access to those VMs in one console so you can manage them all across these 3 environments. So you put App Controller on top, you connect App Controller to the different, let's say, stamps you have on-premise, the service provider, and the Windows Azure, and then from one console, you can control all those resources that you're then driving across these clouds. So if you look at App Controller, what you can do in here is that you can do basic operational stuff as stopping and starting, provisioning new VMs. You can also scale them up, scale them down. And as a last piece, you can actually also migrate a virtual machine between your on-premise and up into Azure if you want to do that. So the other thing we are coming with is that with System Center SP1, we came with the first version of Windows Azure Services. Now, what is that? So what we have here is we have a service management portal that provides you a GUI where you can go in and you can do common sets of services that you provide within this portal. So what comes out of the box is websites and virtual machine, a service bus, as well as the opportunity to plug in third-party tools. What we have in between here is what we call the Service Management API, and that's another thing that we talked about. So when Brad is saying that we want to have a consistent experience across, this one also goes for the APIs, meaning if I'm developing something against this API, it would be very, very easy for me to develop a similar solution that points up into Azure because the API that we're using are the same. What we're also working on, I don't know if, have any of you heard about SMA? Okay, Service Management Automation. What that is a new workflow engine that we put into the Windows Azure Pack as on the back end at the same layer as for Service Foundation, where you can describe automations that you want to perform on the back end of creating virtual machines or websites or similar things. That is also a standard that we're working on, bringing that between the clouds. So once you have defined a runbook there, it becomes very easy in the future to move that to other places and reutilize that there. So we have the Service Management API, then we can provide the services as websites, virtual machines, and databases, and then people can log into this portal and start consuming these services. So here we have a controller, we have a web farm, on the top of under that we have Windows Server, and then we have websites. On the VMs, we have Service Provider Foundation, then we have System Center Virtual Machine Manager, and under that we have Windows Server, or other hypervisors that you can then use to do that. And then we also have third-party partners that does a plugin. Parallels is one, Apprender, Sorara, and also Cloud Cruiser are all partners that are working on solutions to extend the Windows Azure Pack. So what we're really doing here is that we have on the left side, your left side, we have the Windows Server. On the right side, we have Windows Azure. So what we're doing here is to take the self-service portal and move all those capabilities down to on-premise. At the same time, we also take the common management experience on the way that you create users, the way that you talk to the backend, things like that, and take the learnings from that on Windows Azure and move that down to on-premise. And we're actually also working on some of the capabilities we're building in here on Windows Server side and move that up into Azure. And then we can enable services to move on-premise. So some of the ones we have there, like web services, VMs, and SQL, that we can use that in the same way. And then we use traditional system management underneath with Virtual Machine Manager, where SPF would then provide the communication into there, similar to the way that we do it up in Windows Azure. So just to summarize a little bit how we build this is that first, we get in and we build the fabric side of this. We build a fabric cluster, just a traditional, we started with a 16-node cluster, build that up, got it up and running. We connected with Fabric Network, where we either use the traditional SAN, we use the scale-out file servers, but also use the direct attached storage. And then on top of that, we did the Fabric Networking, where depending on where the service provider was in their networking experience, we start building up the standards around that. Once we've done that, we build the management part of the solution, where we put in the management cluster, put Virtual Machine Manager, Orchestrator, and Operations Manager inside that, and then we build the Windows Azure Pack admin side of it. So Windows Azure Pack has two sides of it. It has the user portal that we normally want the tenants to log into, and then we have the admin portal where we can go in and start to define new tenants. We can start to define what we call plans that users can then subscribe to, such as virtual machines, websites, and SQL servers. So that was defined there. Then the next step was to, at the web tenant, define that layer there, where we had the web tenant part of the website. So customers could then and connect that to the admin side of it. And then we have App Controller, or the Windows Azure Pack, exposing that to the internet and have people log in there. And then App Controller connecting that up to Azure if there was a requirement for that. So what we're saying here is, when should I use App Controller and when should I use the Windows Azure Pack? A lot of service providers asked about this, and I would say if the service provider has customers that has an explicit requirement for getting access to their on-premise, to the hosting, and to Azure, you should think about using App Controller. If there's not such a requirement for doing that, we would recommend that you look at the Windows Azure Pack and let that drive there. What we learned also is that customers that already had a portal was very interested in the Azure API itself, because that gave them a standardized interface to talk up against, where if they were considering starting on a new portal, they loved the Windows Azure Pack, what came out of the box, because it gave them a building-based platform to start from, and then they could put their own kind of Legos on top of that with what they wanted to offer besides what comes out of the box. So many of them saw that as an easy starting point and then build on top of that. And then also what they liked about SPF is that it solves their problem of having to authenticate a user and how to map that user into the backend resources that user would then have access to. So that was a pretty big help for them. So we just want to spend a little bit of time on tools that can help you. So one thing we want to make sure is that when you go out this door here, that you don't start from scratch and have to go out and learn all the things that we did over the past 12 months. So there are certain things that we utilize in these implementations that we want to point you to. So hopefully that can give you a good head start. The first one is what Ricardo talked about, is these management patterns or fabric patterns that we used in many of the customers. And we have put those freely available for you. And you can see here, the first one is the infrastructure as a service product line architecture, fabric guide. This one will talk about how do you put together what we did in the first phase. What should I do about my storage? What should I do about my networking? And what should I do about my compute? What is required as technologies to do that? What do we recommend? And what are areas you should try to avoid when you put this together? So these documents are the ones where we encourage you to sit down and read them end to end. And then after reading it, you will have a much better understanding of how to walk this path and how to avoid the bumps on the road. The other one is the management guide, and that's the one we want you to read when you build the management cluster that I talked about, how to set that up, and what questions to ask yourself, and what decisions to make before building that. So it would have all the things that we had to think about when putting together that management cluster, and what things that has to be there in order to successfully implement that. And then there are the last two that was just released. The first one is the infrastructure as a service deployment guide. Obviously, that talks about how you should deploy these and in what order and what to think about when you do that. And then the other one is infrastructure as a service guidance for service hosting providers. Now, this is kind of more both Ricardo and I did review on this document, and both of us found it very, very valuable in a way that if you're a service provider, it's a good idea to sit down and read the last document up there kind of as a checklist of things that you should care about before you get started. So it's more conceptual things that it talks about, where it says, we want you to make these considerations around billing or around chargeback. We want you to think about this when you do access. We want you to think about this when you do release and change and such things. So it's really from a conceptual high level, but when I read it, I went, oh, that's a really structured approach to take. So if I kind of go through all the things that are listed in this document, I kind of get more confident that I'm not leaving anything behind. And I'm not kind of unchecking something. So when I go in full production, certainly I'm standing there saying, whoops, I should have thought about that. So use the last document there as a checklist that you haven't forgotten anything. Anything you want to add to that?
No.
Okay. Then the PowerShell deployment toolkit, that's actually did any of you went to that session that was prior to this one? Okay. That is a colleague that works on the same team as I do, called Rod Willis, that has created a PowerShell deployment toolkit that would help you install System Center in a very standardized and automated fashion. So it's a PowerShell script framework that specifies. It asks for a lot of information from you, like what are the names of your different servers, where do you want to put the databases, the different System Center components. So you have this input file that you fill in, and then you describe what you want your environment to look like, if you want cluster SQL, or if you want Ops Manager, Service Manager, Config Manager, and Virtual Machine Manager. And once you have typed in all this, it will build a complete system center management infrastructure for you based on that information. And if you're interested in kind of doing that and looking deeper into that, I would recommend that you go to the blog that we have on the team called Building Clouds. So search on Building Clouds and System Center, and this will come up where there's a lot of blog posts on how to use PowerShell Deployment Toolkit. And you can actually see the link down there, private clouds, and then deployment track. The next tool is actually also developed by another guy called Jim Britt on our team, where he has created what I talked about before, the advanced workloads that many service providers want to deploy for their customers. In this case, it's SharePoint. So by using what we call IT services, templates, and virtual machine manager, you can, in a very automated and standardized way, deploy SharePoint into a tenant and then fully setting up that infrastructure without having to go out and do a lot of manual steps on that way. And you can see the link to that track down there. So if you have customers that are screaming for SharePoint and say, we want that now, and we should have had that yesterday, this is a technology, and it's fully described how to do it, that you can go in and explore to understand how you can automate that using System Center. Then the last thing I just want to point you to is some of these service providers we were talking to were using either other virtualization technologies, or they had a lot of physical infrastructure that they wanted to move to a virtualized environment. And here we have a person on the same team called Mark Gusson. He also did a session this week on this, where he talks about how you can easily migrate virtual machines from VMware onto Virtual Machine Manager. Here are some of the sessions that most of them have already happened, but if you're interested in getting more information about the areas we talked about, you can go for these sessions here. And then if there are any questions, we can take those afterwards. But what I want you to very strongly encourage you to do is to give us the evaluation. We really want to think about if this was valuable to you, if there's stuff we should have talked about that we didn't mention, and really other kinds of feedback that you might have. So please spend the few minutes that it takes to fill in this. We'd be very interested in getting that feedback. Any closing comments?
Questions?
Yeah, of course. Any questions? No? You're more than welcome to come up here if there's something you don't want to talk about in a big audience. Come up here as well. We are very happy to talk to you. But I guess with that, we want to say thank you very much for staying this late.
Thank you.
And we take it as a sign to us that all of you stayed all the way through to 6 p.m. as a contribution that at least some of this was usable. So thank you very much for your time, and have a great TechEd.